Hey folks, welcome to my channel Number Pen. There we have the problem on the screen. Integrate the following with respect to x. We have x to the power 5 into e to the power x square. So what we've been given is dy by dx and we've been asked to find y. And my y is nothing but integral of the given expression. So let's write down our y using the integral symbol. That's my y. I know that my y is not in a very simple format whose antiderivative I know from first principles. But then I see that I have two expressions within my y, right? I have a e to the power x square and I have an x to the power 5 dx, right? So I know very well that this is a problem which I can solve using integral by parts. But then I request all my folks to take a look at the problem once again and see if I can simplify this before I jump to application of integral by parts, right? Now I have x to the power 5 and then I have an x square in the e to the power expression, right? Now can I rewrite it and do a simple substitution that makes my y a lot more simpler than what it looks right now, right? The answer is yes. And why is that? Because my x to the power 5 can be rewritten as x squared times x squared times x. And then now things should become a lot more clearer to you folks because I have x square and I know that d by dx of x square is 2x, right? So what is it that I need to do in my next step? I need to multiply and divide by a 2, right? So what I get is 1 by 2 times, I pull that out of the integral. Integral of x square dot x square dot 2x, I can do this, right? 2x dx dot e to the power x square, right? Now I'm going to make that substitution that's going to make y simpler in the subsequent steps, right? So t equals x square, right? Now when my t equals x square, my dt becomes equal to 2x dx, okay? And therefore, my e to the power x square becomes e to the power t, okay? So I go back to my y, and when I rewrite my y, I'm going to write everything in the form of t, right? So I get 1 by 2 times integral of x square times x square becomes a t square, okay? And then I have a 2x dx which becomes a dt, and then I have my e to the power x square which becomes e to the power t because my t equals x square, right? Now I know that this is something that we can solve by using Bernoullis identity of integral by parts, or you may solve by application of integral by parts successively. You may have to apply it twice, right? So I'm going to put down what my Bernoullis integral by parts states and solve this particular problem, right? So there we are. This is what my Bernoulli's integral by parts tells me. If I have an integral of the type integral of u dv, then the answer to that problem is uv minus u dashed v1 plus u double dashed v2 minus u triple dashed v3 plus integral of v3 times u dash 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 dx. So dash represents the successive derivatives of u and my v1, v2, v3, etc. represent the successive integrals of v, right? So let's write down what is my u and v. And like I have solved problems in the past, whenever you have an expression of the type x to the power n, right? as one of the parts in the UDV, then choose that to be U. And I've explained in my previous videos why is that. So in this particular case, we will have to take U equals T square and my dV equals e to the power T dt, right? I have my U, I have my dV, okay? Now I'll have to go ahead and pick up my first, second, and third derivatives of u, right? So my u dash equals 2t, and my u double dash equals 2, and my u triple dash onwards, I get a 0, right? So I don't think I will have to really worry about anything beyond my u double dashed, right? Let me highlight this particular portion in pink where I have a U triple dashed and a V3, right? And that is followed by an integral of V3 times U, let me call it 4 dash times dx, right? So that portion which I've highlighted in pink becomes a 0, right? And therefore my integral of U dV, I go to the next step, becomes a lot more simpler, right? And imagine if we had a very complex expression instead of t square, let's assume we had t to the power 6, right? Then you might have had to expand Bernoullis integral by parts further. So we don't have to do that now in this particular expression because I realize that my u triple dash becomes a 0, right? So my integral of u dv is nothing but uv minus u dashed v1 plus u double dashed into v2, right? So I have my u dashed, I have my u double dashed, I have my u triple dashed, which is a 0, so I don't have to worry about it. Now I come to my v portion, my dv equals e to the power t dt. So what is my v? My v is again e to the power t, right? And now I come to my v1. What is my v1? My v1 is the first successive integral of v, which means it is integral of v dt. My v1 is nothing but integral of v dt, and my v is nothing but e to the power t. So I end up with e to the power t once again, right? And now I go to my v2, right? What is my v2? My v2 is the second successive integral of v, or the first successive integral of v1, which means it is integral of v1 dt, okay? Which means again I will end up with e to the power t, right? So I know that I don't have to go beyond this, right? So I can go back to my udv expression, and what is my UDV. Remember, folks, we will have to come back to this y because I'm not going to take my 1 by 2 element into the UDV right now. I have integral of t square times e to the power t dt solved using Bernoullis integral by parts. So what is my UV? My u is t square, my v is e to the power t, right? So I get t square times e to the power t, okay, minus u dash is 2t, okay, and my v1 is again e to the power t, okay, and I have a u double dash which is a 2, and my v2 is also e to the power t, right? And then not to forget my constant plus c, right? Now I have my answer for integral of t square times e to the power t dt. Now I can go back to my y and write down my answer for half of integral of t square into e to the power t dt, right? So y equals half of, okay, and all that I need to do is copy paste whatever I derived earlier, right? So this is what I get. Now When I take a close look at this, I know that I can do a little bit of simplification. Half of t square times e to the power t, okay? And then for the remaining two expressions, I know that I can cancel out my 2, so I get a minus of t into e to the power t, and then I get a plus e to the power t. So there I have my answer for y. But everything is in the form of t, and I'll have to put back everything in the form of x, right? Now that's not very complicated because I know that the substitution that I made is t equals x square, right? So what is my t square? My t square is nothing but x to the power 4, right? So, and my e to the power t is nothing but e to the power x square. So my answer to this problem is half of x to the power 4 times e to the power x square minus x square times e to the power x square plus e to the power x square plus c, right? Let me highlight my final answer in pink. I hope you found my content useful. Please do subscribe to my channel and support. Thank you.